Hello everyone, myself Anurag Mondal, Assistant Professor of EC Department. Today I'm going to introduce one of the basic, conceptual and important subject in the CS Department second year, that is Digital System CS 304. In this particular session, I'm going to tell you why digital system or digital electronics that is related with the electronics department is most important and the conceptual subject in the CS department. Why we are going to study in the CS department and what is the story behind it. Then I will tell you what we are going to study in this particular series of lecture of digital systems. And at the end, I'm going to tell you the reference books that we are going to use in this particular series of lecture. So let's start. Why we are going to learn in this CS department of this particular subject, that is digital electronics or digital system. First of all, whenever the CS computer science departments come in our mind, then and then this image of the system or computer system that's strike in our mind then and then. What is this system? This particular system having some display unit, some unit device, input device, some output device, central processing unit, and some storage device. That is the combination of all these particular devices are the computer system. And what CS department do? They just programming various objective in day-to-day life, okay, within this particular system. But one thing, even if you program or solve your objective by programming, but is there any provision for you to implement that program into the real world? For an example, I just tell you one of the example regarding the ATM. In the ATM machine, you just programmed that if someone going to withdraw 10,000 rupees, okay, and all the money he or she will withdraw, the currency present in the ATM, that is 500 rupees, okay. Then obviously after entering that 10,000 amount, the equivalent amount of 500 currency note will be provided by the ATM machine. Now our objective is to programming that function of the ATM machine. That means if the sufficient balance is not there, then and then after typing that 10,000, our machine will display that insufficient amount, or after just typing the 10,000 amount, that machine will show that currency you want in terms of 100 rupees or 500 rupees, that much of things. So you can program with any kind of language, but even if you program that thing, can you able to implement that program into the real world? For implementing that program into the real world, you need a machine, that is the ATM machine. So you have to first store that particular program within some controlling unit, and that controlling unit also having some processor that can process that particular program. So Without hardware, you are not able to move a single step in the real world, even though you solve each and every objective with the help of programming languages. And to design that particular hardware, we need to know the logic behind the program, how that program will run, what kind of signal the particular processor will provide, what kind of operation that particular process will do. Each and every process we have to implement with the help of hardware. So that is why our CS department need the knowledge of basic electronics. Now comes to this image. This image is nothing but a computer system. In this computer system, what we have? Some input device, output device, system unit, and mass storage device. Now, when this output device or input device will operate, means we have to provide a trigger signal or a signal to initiate this particular output or input. Yeah, you just program it that whenever the click in the mouse, then and then some file will open. That is okay. But when that signal will generate, that is the story behind it. And that signal is nothing but a digital signal that may be in terms of 0 or that may be in terms of 1. So to trigger the output device or input device, or to initiate the operation of the output device or input device, we need the concept of digital electronics. All the control, arithmetic, and logical operation within the system, that is all the digital signals, that is in terms of 1 and 0. Okay, so whatever the arithmetic operation is doing within the particular controlling unit or system unit, that is addition, subtraction, multiplication in terms of addition, or division in terms of addition, all kind of arithmetic operation, that is done with the help of the digital electronic concept, not with the help of programming. You have to design that arithmetic circuitry within the system unit. If you doesn't implement or design that arithmetic circuitry, even though you program that a plus b should be there, that a plus b never be implemented. All the logical operation, like you have learned about this kind of logical operation like and logic or logic, like this. All the logical operation is the concept of digital electronics. So you have to learn that digital electronics subject, or you have to gain that kind of knowledge. Fourth is designing of digital circuit according to the application. Already I have discussed with you about this particular point. Means, yeah, you have to add some two number, but you have to implement that addition operation in terms of circuitry within the central processing unit. Then only the addition will perform. Otherwise, even though you in the program you just write down a plus b, then also the addition will not perform. And the fourth point is implementation and designing of the storage or unit or memory. So implementation of any storage unit or memory, we are aware with the storage unit or memory. that is pen drive, then we have the memory card, then we have the external hard disks also, and we have the internal hard disks also in our computers. If we talk about the storage unit, all the data stored in the storage unit in terms of 1 and 0, and that particular 1 or 0 have to store with the help of some technology. That is the flip-flop that we will discuss in this particular series of lecture in the future classes. But with the help of flip-flop, we have to made one register, and within that register we have to store the data in forms of 1 and 0. So we have that kind of concept, that which kind of circuitry store the 0, which kind of circuitry store the 1, or when it will store the 1, when it will store the 0. Everything is the concept of digital electronics. So it is the basic, and I can say the most important subject in the CS department, because if you know the concept of all digital electronics, then you are able to design your own circuitry that you are going to apply in the day-to-day life. You are the master of program, you just programming one particular object, but after getting the concept of digital electronics, you can apply that program into the day-to-day life or practical world. So that's all about the concept, or why we are going to learn in the CS department this subject. Okay, so let's move on. What we are going to learn in this particular subject or series of lectures. First unit, we are going to learn about the basics of number systems. Then we are familiar with some binary codes, then Boolean algebra, then NAND logic, NOR logic, and its implementation. And one of the most important topic in the whole digital electronics, that is the Carnot map method, because this topic is much more important. Each and every unit, whatever the topic we are going to study, that is based on the Carnot map. Okay, so we have to learn this Carnot map very efficiently or very brief way. Okay, next, in the control unit 2, we have to learn about the adder, subtractor, BCD adder, then serial adder, parallel adder, then multiplexer, encoder, decoder, arithmetic circuit. We have just discussed about this particular arithmetic operations. Okay, now how that arithmetic operation we can implement into the real-time world, real-time scenario, that we are going to learn in this particular unit, unit number 2, that is the combinational logic. In the next unit, we are going to study regarding the flip-flop, that storage unit based upon the flip-flop, and with the help of flip-flop we can store some data within the memory devices. So we just learn about this particular flip-flop in this particular unit, sequential logic. We have learned about the RAM, ROM also, and how to designing the ROM. We have learned about some ICs, that is the 2716 and 2732, etc. Then in unit number 4, we are going to learn about the A to D converter and the D to E converter. What are the A to A and D to D converter? Analog to digital converter and digital to analog converter. Analog means the real-time scenario, real-time signals, and digital means whatever the signal that is resided within the computers. Next, we are going to learn about the IC555 timer, and this IC555 timer going to generate the clock signal, and that clock signal is important for the memory purpose that we are going to learn. And fifth unit is the introduction of digital communication. Obviously, we have learned about the digital signals and digital electronics. Then what is the importance of that digital electronics or digital signals in our communication in day-to-day life? Yeah, now the digital communication is there. Now we are communicating with each other with the help of video calling. How we can communicate, how the signal will transmitted to the receiver. Obviously we cannot transmit the analog signal. Even though we just transmit the analog signal, there so many noises are there. So that's why the digital communication is introduced. And the digital communication, we doesn't get that type of knowledge or noise or the losses of the signals. And how that digital electronics will help, or digital system will help our digital communication, that is we are going to learn about this thing. Some theorems also there, that is the Shannon's theorems for channel capacity. This particular theorems is very much important in the communication purpose. Then Nyquist sampling theorem is also important. So this is all about the syllabus, unit 1, 2, 3, 4 and 5, that we are going to study in this particular series of lecture of digital system. And at the end, we are moved towards the reference books. These are the 7 reference books. I'm going to introduce each and every book whenever it is needed, and I'm going to tell you from which particular book we are going to cover up the particular topic of the unit. So in this particular session, we are going to learn regarding the importance of the concept of the digital electronics, how much it is important in this particular computer science department. Then we are going through the syllabus, what we are going to study in this particular series of lecture, and at the end, the reference books. So that's all about today. Thank you.